Good morning everyone, I'm Jamin. My metric number is F1124.
Hi, my name is Nur Hasmi, F1025.
My name is Nosha Saidina binti Ishaq. My metric number is F1079.
Today we will present about soil consolidation. Soil consolidation is one of the terms used in geotechnical engineering, which is pertain to the study of soil behavior under loading condition. Soil consolidation may be defined as the time-dependent movement of the soil body resulting from the gradual expulsion of water present inside the pores of saturated soil, mostly clay. In the application of many external load on the soil body, excess poor water pressure is developed. However, as the drainage takes place over time, poor water pressure reduces, thus causing rearrangement of soil particles into denser arrangement. The importance of soil consolidation becomes apparent in the designing of building and civil engineering structure, like roads and embankment. Ignoring soil consolidation effect may lead to undesirable results such as settlement or instability of the structure. Hence, the properties associated with consolidation should be studied. Now, soil consolidation may be explained as the phenomenon where soil reduces its volume over time as a result of the expulsion of water in pore space. This happens to saturated soil, mainly clay, subjected to any load such as building load. With the increase in load on the soil, water gets gradually expelled from the soil, leading to the soil settlement. So now, I will explain about the principle of soil consolidation. Principle of soil consolidation is based on Terzaki theory of consolidation. According to this theory, when a load is applied to soil, it is initially supported by poor water pressure. Over time, the water rains out and the load is gradually transferred to the soil particles. This increases the effective stress and causes the soil to compress. And then is the concept of soil consolidation. The concept of soil consolidation explains how this process happens over time. It is not immediate but occurs gradually depending on the soil type and drainage condition. In engineering, this concept is very important because it helps predict how much and how long the ground will settle, ensuring safe and stable construction.
So for today, I will explain about the soil consolidation of construction. The soil consolidation process begins when a load such as a building is applied to the ground. This increase our pure water pressure inside from the soil. So that means so we apply the building into the ground, then the water inside from the soil, like that. Then the water start to flow out slowly through the soil. Next, the soil particle rearrange themselves into the higher structure. Finally, settlement happen gradually over time. This process may take a long time, especially in a clay soil. This is because a clay soil has an extremely permeability, making it difficult for water to escape from its tiny pore. When a subject a lot, usually clay soil take a month or years to dissipate. This means clay soil is very difficult, but can. This is very difficult, but can. The very difficult for the water inside from the soil. So let me give example construction use soil consolidation in Malaysia. For the example is Petronas Twin Tower in Kuala Lumpur. The tower we built on a site with limestone and soft soil, which is created a risk of uneven settlement. So engineer used the board piles and rough foundation to transfer a load to a stronger ground. These methods help to control settlement and ensure the stability of the structure. This show the importance of considering of consolidation in a major construction project. So the next slide, this diagram show the foundation system of the Petronas Twin Tower. At the top, we can see the building structure which transfer down to the foundation. Just below the structure is the rough foundation, which help to distribute the load evenly. So below the rough, there are deep bore piles. This pile extend very deep into the ground, like 18 to 100 meter. So the function is to transfer the load from the building to a stronger layer underground lah. So in this case, the piles reach the limestone bedrock, which is much stronger and more stable compared to the soft soil above. So the soft soil layer in the middle is compressible and can undergo for consolidation. If the building relied only this soft soil, it could lead to excessive settlement. Therefore, the use to deep piles help to reduce the effect of the soil consolidation and ensure the stability of the structure. Okay, so this picture show the process to start the process called consolidation before the construction start. So for the first picture is when the building is construct on a soft soil, the weight of the structure applied a lot on the ground. So the rough foundation help to distribute the load evenly lah. So for the picture 2 is the soft soil beneath constant water. It is poured under the applied load. Water start to drain slowly and soil particle rearrange themselves. Also the picture 2, this is the start of the consolidation in this construction. And the picture 3 is the board piles are used to transfer the load deeper into the limestone bedrock, reducing settlement and ensuring the stability of the structure. Just like that. So I will pass to my friend.
I would like to present about term use. The first one is volume compressibility, MV. Okay, in the construction of high-rise buildings such as the Petronas Twin Tower, the structural load applied to the ground is extremely large. Therefore, the soil beneath the foundation must be able to withstand high stress without excessive compression. The parameter volume compressibility MV is important because it indicates how easily the soil volume decreases when the effective stress increases. A high MV value means the soil is soft and highly compressible, which may lead to the large settlement. Okay, for the formula to find the volume compressibility, we use M sub V, which is delta E divided by the product 1 plus E naught and delta sigma prime. Okay, for calculation example, if the change in the void ratio is delta E equal to 0.12, the initial void ratio is E equal to 0.90 and the increase in effective stress is delta sigma equal to 100 km per meter cube. The calculated MV value is 0.00063 m meter cube per kilonewton. This indicates the soil has a relatively high compressibility, which can cause inefficient settlement under the heavy load of the of a structure such as the Twin Towers. Next, I would like to present about coefficient of consolidation CV. In the last construction project like the Petronas Twin Tower, settlement does not occur instantly, especially if the soil consists of soft clay. This is because clay has low permeability, so water escapes slowly. The coefficient of consolidation CV is used to determine the speed of consolidation, which represents how fast excess pore water pressure dissipates. A small CV value indicates that consolidation will take a long period of time. So, for a formula for the coefficient of consolidation is C sub V is calculated by dividing the permeability K by the product of the volume compressibility M sub V and the unit weight of water gamma W. And for instance, if the soil permeability is K equal to 1.0 times 10 negative 9 meter second, MV is 0.00063 meter square per kilonewton, and the unit weight of water is 9.81 kilonewton per meter cube. The calculation civic value is 1.62 times 10 negative 7 and m meter cube per second. This low CV value suggests the consolidation is very slow, meaning settlement may continue for many years after construction. Okay, next is degree of consolidation. The degree of consolidation U is used to determine the percentage of consolidation complete at a certain time in a major construction project such as the Petronas Twin Tower. Monitoring U is important to ensure that the soil has achieved sufficient settlement before continue for future construction stage, as incomplete consolidation may cause long-term settlement problem. Okay, for the formula, the degree of consolidation U tell us the percentage of total settlement that has occurred at a given time. Okay, for calculation example, if the final settlement is estimated to be 300 millimeter and the settlement recorded at a certain time is 180 millimeter, then the degree of consolidation is calculated as 60%. This means that only 60% of the total settlement has occurred, right? And the remaining 14% settlement may still happen in the future. Okay, next is time factor TV. The time factor TV is a dimensionless value used to relate the time required for consolidation with the coefficient of consolidation and the drainage path. In high-rise constructions such as the Petronas Twin Tower, TV have engineers estimate how long it will take for the soil to reach a specific degree of consolidation. This information is important to decide whether soil improvement methods such as preloading or vertical drains are required. Okay, for the formula, the time factor T sub V help us understand how long it takes for the soil layer to consolidate under a given load. Okay, for the calculation example, if CV is 1.62 times 10 7 meter square per second, the time is 200 days, and the clay layer thickness is 4 meter under double drainage condition. The drainage part is HD equal to 2 meter. By substituting these values into the time factor equation, the calculated TV value is 0.70. This indicates the consolidation requires a long time, which must be considered in construction planning. Okay, next is rate of sentiment. The rate of sentiment describes how quickly the ground surface settles over a period of time. In the construction of tall structures such as the Petronas Twin Tower, monitoring the rate of sentiment is essential because excessive sentiment speed can lead to the foundation instability, structure cracking, or differential settlement between building sections. Okay, for the calculation example, if the sentiment increase from 50 mm to 130 mm within 4 months, the rate of sentiment is calculated as 20 mm per month. This indicates a relatively high sentiment rate. An engineer must ensure that the sentiment remains within safe limits by using appropriate foundation systems such as pipe foundation.
Okay, so this when we do the consolidation, of course we have the main problem for related to the soil consolidation. For the first is excessive the settlement occurs when the soil compressed too much under the load, cause the structure to sink. So second, differential settlement happens when the different part of the ground settle unevenly. This can lead to crack buildings and structural damage. Next, long-term settlement is common for clay soil because clay soil have a low permeability and very difficult for water inside from the soil. Where consolidation continue for many years. Then another problem is structural damage, where crack may appear and affect the stability or safety of the structure. So, have a problem, we must have the solve the problem. So the first method to solve the problem is preloading, where extra load is applied before construction to speed up the consolidation process. And two, vertical drains are also used to allow water to escape water from the soil. These are good for the clay soil. So actually the foundations such as a pile are used to transfer the load stronger soil or rock layers. That's it. Thank you.
In conclusion, soil consolidation plays a crucial role in ensuring the safety and stability of large-scale structures such as the Petronas Twin Tower. The tower was constructed on challenging ground conditions consisting of limestone and clay, which are highly susceptible to settlement due to consolidation. Without proper understanding and control of this process, the structures could have experienced uneven settlement, leading to crack, structural damage, or even long-term failure. By applying the principle of Terzaki's theory of consolidation, engineers were able to predict the rate and magnitude of settlement before construction began. This allowed them to design appropriate foundation system, such as deep pile foundation and rough foundation, to effectively transfer load to stronger soil layer and distribute pressure evenly. Furthermore, continuous monitoring during and after construction ensure that the consolidation process remain within safe limit. The successful construction of the Petronas Twin Tower demonstrate the importance of geotechnical investigation, proper design, and the application of soil mechanics principle in overcoming difficult ground conditions. Overall, soil consolidation is not just a theoretical concept but a critical factor in real-world engineering projects. Its proper analysis and management are essential to prevent structural issues, ensure long-term performance of granting the safety of infrastructure. The Petronas Twin Towers stand as a strong example of how engineering knowledge can successfully address complex soil challenges.